Şimdi Kevin Richard'ı sahneye davet ediyorum.
Hi everyone. My name is Kevin Richard. Actually, it's Kevin Richard since I'm French. So I think that since I am in Istanbul, Turkey, I should try to say one phrase in Turkish, right? Merhaba arkadaşlar. Kusura bakmayın ama Türkçem biraz şatpat olduğundan dolayı sadece İngilizce kullanacağım. Ama isterseniz sunumumdan sonra Türkçe konuşabiliriz yüz yüze. So, Paris. So today we will talk about a ranking factor study we ran. So this is the team. This is myself. So the study has been conducted by myself, monitored by this guy right here, whose name is Sylvain Perronnet. He's the AI director at Quant, which is a French European search engine. And I'm also very grateful to Yiğit, who provided all of the keywords data for Turkish market. So that's why I mentioned him as Baba. I think it's pretty accurate. So, we wanted to conduct a very specific study. And to my knowledge, this is the first time it has been conducted on Turkish search results. So, this is the very exclusive content we are providing you today. And dozens of hours of work and liters of coffee have been spent in order to get something showable to you today. So, our question is, can linking metrics alone predict rankings? So I know this is a rather audacious assertion. So it means that our only predictors or variables were the linking metrics alone. So in other terms, we didn't want to give a look at any other variable, such as speed, or social signals, or content length, or content optimization. So anyway, defining what is a good or a bad content is quite hard, I mean, in order to conduct a study like this. So we said, hey, let's take only the linking metrics and let's try to create a model for this. So this is the methodology. We wanted to check only on google.com.tr. We monitored 100,000 non-branded keywords, and we always took the top 100 results. And we wanted, so I said non-branded keywords. We wanted to get rid of any indicator, of anything that indicates that a keyword is navigational. So either it was a knowledge graph, either it was like always the same domain in the first positions, or either it was like a big site links. So we got rid of this always. So why did we do this? Because we assert that navigational or branded keywords already contain or imply the website the users wants to go on. So for example, if I ask Google Sahibinden or I don't know, Sahibinden plus city, Sahibinden Ankara, Sahibinden Istanbul, then Google will understand I want to go on sahibinden.com. He will always understand this, so the linking metrics in such keywords are not that important. This is another assertion. This is something we saw on our French version of this study, so we wanted to get focused on non-branded keywords. So for linking metrics, we decided to use Majestic metrics, Majestic data. So Majestic is not Google, of course, but it's a company, an English company. And also one of our assertions was that a regression test is not enough. I think it was in Digitalzone last year, or maybe the year before, where some guy from Distilled showed that flipping a coin was more accurate than a correlation test. So we wanted to get rid of this. So this is a SERP for the keyword coffee table in Turkish, orta sehpa. So the methodology is, okay, taking the SERP and ranking it 1, 2, 3, 4, 5. Okay, not need to be a genius for understanding this. So we had 100,000 times this kind of SERP, and we ranked all of the results. Then, this is where it becomes a little bit nerdy, but there is nothing to panic about. So we have different types of linking metrics. So a linking metric can either be a number of backlinks, a number of referring domains, or it can also be considered as a flow, like the PageRank. You can imagine this as some juice. This is your home page, and then if you use internal linking to send the juice to different URLs, then the juice from the home page will flow until your first URL, second URL, etc. We have two kinds of flows, trust flow and citation flow. It's a little bit difficult to explain the difference between them, but okay, trust flow is all about trust and having only backlinks from high-quality websites, and citation flow is all the backlinks ever. If you spam a lot, your citation flow will increase, but not your trust flow. And the ratio between the two of them, TF divided by CF, is the quality of your website. If you don't have lots of quality backlinks, but lots of backlinks from spam, then your spam score will be high, since your ratio will be low. Okay, and referring domains, well, it's referring domains. So in order for you to understand the difference, I showed you these metrics history for my website. So as you can see, the black curve here is my number of referring domains. It goes up 2 times, but why does it go up since my trust flow stays steady? It's because it was a spam attack. So all of these referring domains didn't have any impact on my trust flow. But there, at this very moment, at the end, at this very moment, I had only one new backlink from a very highly quality website, highly trustworthy website. And as you can see, my number of referring domains stays steady, but the trust flow increases. So these are some examples of trust flow. It goes from 0 to 100. Twitter is 100, Google.com is 99, Google.com.tr is only 51. You already know all of these websites. Maybe not Oyun Kolu. I didn't know this website either. I just typed war game in Turkish, Savaş Oyunu, and I found this website who was ranking first. But I mean, you can understand that it's a score of quality. So, this is the most crucial part in our study. So I will explain it later with some examples. So we will compare ranks with ranks. We have 1, 2, 3, 4, 5 until 100 for the position, for the ranking. And then we didn't want to give a look at absolute values of trust flow, like maybe it's 10, maybe it's 100. We wanted to rank them. Okay, this is the biggest trust flow in the SERP, so it will rank first in terms of trust flow. This is the biggest number of referring domains, so it will rank first also. So we will list the top 100, grab their metrics, and get a rank for each metric. It will give us relative values. And then we will create a model that answers the question, does this URL belongs to top 1, top 3, top 5, or top 10? I will explain later how we created this. So let's take again our Orta Sehpa example, and let's grab all of the metrics for every single result. These are the URL, and then we take all the URLs, and for both the URL and the domain, we grab the metrics. We have trust flow, citation flow, ratio, number of referring domain, etc. So in order to explain this better, we will order the data. Like this one, 58 is the biggest trust flow on the SERP, so we will rank him first. Then the second one is 48, we will rank him second, etc., etc. So that we get rid of, maybe on a certain SERP, there will be very high trust flows, but on another one, there will be very low. So then, in order to sum up, we take the 100 results, we record each relative linking matrix, we repeat this 100,000 times, and then you get a 10 million records dataset. So this is, for example, on Orta Serpa, the first position is hepsuburada.com, URL item, this is the URL which is ranking, and then you have the different ranks. It appears to be the biggest, the URL that has the biggest amount of referring domain on this SERP. To sum this differently, 100,000 keywords gives all of this big database, and then we will take randomly in this database 2 million random non-branded keywords. We did this 3 times, just in order to be really sure that it was not because our randomness wasn't so random. So we conducted the study 3 different times. And then on this set of keywords, we divided them between training set and testing set. What is the difference between training and testing? This is some machine learning explanation. So the difference is the difference between a dummy boxing partner and a real partner. So we want to train our algorithm against a dummy, and we don't want our algorithm to be only specialized in fighting dummies. We want him to train him and then to send him blindly on a real dickhead like this. And this is called cross-validation. Sorry for my vocabulary. So this is the difference. So this is our keyword sample. There are lots more keywords. By the way, I manually looked at the keywords, and this is like Turkish people always search like games, series, maybe Dizzy, gambling, iddia, congratulations, and porn. So, by the way, Yeet, is this the real data set, or is this your personal browser history? Just to make sure. That's cool. Oh. So, we did a correlation test. And the thing is, this is a choreogram, okay? We take all of the variables, we match them together, and we try to detect the darkest areas in order to see if there is a correlation. The only thing that we are interested into is the position row. Here, this one. I will zoom a little bit. What can we notice here? Well, let us get this straight. Absolutely nothing. We cannot notice anything. As I told you, correlation test, linear regression is not a good thing in order to conduct this kind of study. So we wanted to go a little bit deeper and find a new, more accurate algorithm. So maybe you know this game. This game is, in French is Qui est, in English is Guess Who, and in Turkish is Bil Kim Bakalım, I think. Maybe you, who knows this game? Who knows this game? Okay, so half of the room, that's fine. So for the people who don't know this game, you have a card. This is the character you chose, and you have to guess your opponent's character by asking questions. Like, is your character a woman? The other person's, your opponent says yes or no, and then you will, according to his answers, you will flip all of the cards until you are left with only one card. Does he have glasses? Does he have big eyebrows? I don't know. And at the end, you will guess your opponent's character. But this is more or less what is a decision tree. You always ask questions in order to get rid of all of the results you're not interested into. So we did approximately the same. We have created an algorithm. What is an algorithm? Well, it's a word used by programmers when they do not want to explain what they did. It's actually like a black box, okay? So I will explain later what is under the hood. But according to its metrics, is this URL in the top 1, top 3, top 5, or top 10 on these keywords? This algorithm takes this question as an input and also all of the metrics I've introduced before. We ask the question, and the output is either yes or no. So what do we do? I explained you the decision trees. We have put dozens of decision trees, actually 50 different decision trees in our algorithm. By the way, we used Python for the people who are asking. And all of these trees, these 50 trees, gather and they vote and they decide what will be the answer. It's a rather democratic process somehow. And we will be left with a big problem. What is this big problem? Well, the algorithm is lazy, okay? So imagine an algorithm that wants to maximize its success rate. You always ask him the same question. Is he number one? And he will always answer no. Is he number one? No. And is this URL number one? No. You ask him 100 times the same question, and he will always answer no. You see, I've even coded you an algorithm which always says no. And he will be right 99% of the time, actually. He will not have guessed the first spot correctly, but he will tell you, hey, I was 99% of the time correct, predicting it would not be in the first spot. So this is exactly what we don't want. We don't want our algorithm to laugh at us like this, so we will educate him to avoid this kind of crappy behavior. How can we do this? We have two ways of doing this. First, we will do some downsampling. So instead of having a proportion of top 1 and non-top 1 of 1 versus 99, we will adjust the proportion and we'll have maybe 30 versus 70. This is called downsampling. So the algorithm has to take risks. Otherwise, if he always answers no, he will be 30% of the time wrong. So he has to train again and again. This is the first thing we are using. The second is we will raise the penalty for each mistake. So if he cannot predict correctly some positions, then, for example, this is what we do with a balanced random forest script. So in our situation, if he is correct, he gets no penalty. If he says no instead of yes, he gets 0.5 penalty. But if he says yes instead of no, he gets a 50 penalty. So we train him so that by raising the level of the penalty, he will understand that there are some mistakes that should not be done. I will end a little bit with overfitting and underfitting. So this is, I put the source of where I found this great screenshot. This is what we're looking for, okay? We want to separate the top 1 or top 10 position and the non-top 10 according to different metrics. A bad algorithm would do something like this because he's underfitted. It's when a model does not fit the training data, and therefore it misses the trends. And it also means that the model cannot be generalized to new data, to unknown data. And overfitting, on the contrary, it's when we have trained so well our algorithm that he knows exactly, perfectly, like by heart, the training set. But he only works on the training set. So this is something we wanted to avoid. And, well, I talked about flipping a coin at the beginning. And we wanted to know how well do we perform versus total randomness. Can a dice be more accurate than our model? If the answer is yes, then it will be a great shame. And I wouldn't be here talking. So we added a random value so that we can check how well it performs in front of randomness. So for all of the nerds, this is what is under the hood. Non-braided queries only, downsampling and oversampling. And also we use random forest, 50 decision trees, k-folds cross-validation, and only the linking metrics. So these are the results. Can our linking metrics predict correctly and how often it can work on a Turkish dataset? So we had a we had a 98% success rate by predicting either a URL is in the first place, in the first spot, or not. It decreases a little bit afterwards because I will explain later why. But between us, that's pretty neat. So what is inside of our box? What are the different decisions our algorithm took in order to, in order to correctly predict the spot? So this is the top one prediction. This is the top 3. And as you can see, I will not go very in detail, but as you can see, the first two features were, is the URL, which is ranking, does it have a lot of referring domains, of do-follow referring domains, or not? And the second weight used was, does this URL has lots of internal and external linking towards it? Okay, and this is at the very bottom. We added the randomness, and as you can see, this is the randomness, and I mean the weight of it is very low compared to the top features we used. What is interesting is that these features are pretty much the same, almost the same, between the top 1, top 3, top 5, and top 10. But afterwards, it doesn't work that well at predicting, I don't know, a top 50, for example, because there, this is another assertion, I cannot prove it right now, but below a certain threshold, it's the content that is most important. So, okay, the first weight means that we have to have lots of, not lots, but more than the competitors. We have to have referring domains, do-follow referring domains towards our URL. The second feature means that we have to have both internal and external links. The third feature means that we have to have a domain which shouldn't be too much spammy. And then, yes, I mean, these three features, 3, 4, and 5, work together because this is a ratio. The third one is a ratio between the two. The two next. And after, well, we have lots of different features. I will be glad to explain it a little bit later because I will run out of time. So we have the same results, but explained differently. This is called the SHAP values. So it has 3 different dimensions. What you have to remember is that randomness, I featured it twice. Randomness is a very small cloud. And on the contrary, the rank, the number of referring domains towards the URL is very high and very useful in order to correctly guess. So this is only for the nerds. This is the ROC curve, ROC AUC curve. The more the yellow line is close to 1, the better. So it's quite good. If it was close to this line, to this blue line, then it would be not so good. And it can show and explain how well a model works. So this is for the top 1. This is for the top 3, top 5, and top 10. As you can see, the accuracy decreases. So I said I wanted to compare to randomness, to total randomness. And this, for example, the purple area is not in top 10 or not in top 1. And the green area is top 1. So as we predicted, randomness is the same. Either you're in the top 10 or either you're not in the top 10. So this is randomness. And this is the most important weight used in our model. Do we have lots of referring domains? You can see there is a difference between the top 1 and or top 10 and the non-top 10. This is called class 0 or class 1. It's a meta word in order to explain correctly guessing a position or not. So this is the average, okay? I wanted to give a look at what happens in the whole top 100 results. This is total randomness. As you can see, it's always the same. Either you're in the first spot, either you're not. But with this feature, the number of referring domains towards your URL, as you can see, it has an average which is really high until the position maybe 20 or 30. But afterwards, it goes almost completely random. So, this was audacious, talking about content strategy without mentioning content. Well, so I assume that your content is already great, and the only thing that helps you be better than your competitors are the rankings. So these are some very important points we wanted to stress. The model worked without anything else than linking metrics. And I have to add this, our keyword sample is quite specific. So maybe on some more difficult queries, maybe on some specific queries, it can it cannot work, this kind of behavior. But, I mean, if you have a great content, as good as your competitors or maybe better, then what will help you go further are the linking metrics, the linking values, both in internal linking and external linking. So the key takeaways. Ranking is overtaking your competitors, so you just don't want a specific amount of referring domains. You want to be better than your competitors. So it highly depends on the keyword you are targeting. Of course, being the first on, I don't know, John Le Score, which are the results in live, or I don't know, Evden Eve Nakliyat. This is the first keyword I discovered in Turkey. I was watching the spam comments on some French websites, and there was this guy always talking about Evden Eve Nakliyat. So Evden Eve Nakliyat means moving stuff from one place to another one. And I've been explained that Evden Eve Nakliyat is some kind of mafia in Turkey. We have the same in France with the locksmith, Çilingir, maybe in Turkish, with the locksmith. Sorry? So, yeah, we have the same thing in France. You are locked out of your door. You can't find your key. You have lost your key, or you are locked outside. You call the locksmith. He comes. He opens your door, and then he asks you 3,000 euros. Actually, it happens. It really happens. So the most reasonable thing to do is going to the hotel, spending the night there, and then calling someone else in the morning. So, yeah, it highly depends on your environment. So I wrote build backlinks, but of course, we're not building them. We're not buying them. We're only earning great backlinks, of course, directly to your URLs. If you do this, well, you take your own risk, but it works. It works really great until you get penalized. You have to get used to your URLs. This is really important because sometimes people, they are just posting content on their website and just forgetting about it. Like, oh, we have a sitemap. It will help us to get our content indexed by Google, but we don't want to get indexed, we want to rank, and we want to rank better than the competitors. So this is a story about a client we had in France. I mean, it was close to Christmas, and he absolutely wanted to rank for a specific keyword, and it was one of the biggest websites in France, selling website. I know the term in Turkish, e-ticaret, but in English it's e-commerce, maybe, I don't know. Look, I've become Turkish. So he wanted to rank for a very specific product, for a very specific keyword. And he was like, we have our page, it's already well optimized, what can we do? And he was like, maybe I will order you guys some backlinks, maybe we should buy backlinks and all. And we were analyzing the whole galaxy of his websites. And we were trying to check one of their competitors. And we said, hey, this site is ranking pretty well. He said, oh, yes, this is our website too. I was like, okay, this is your competitor, but it's also your website. He said, yes. So we told him, hey, just ask a backlink from this place, from your not competitor, for yourself. Just ask a backlink from here. He put the backlink 1 week after, he was in the first spot. So, I mean, if you have really important keywords you want to target, look at your whole galaxy of websites. Look at, I don't know, at how you are doing internal linking, and just try not to spam, but to get legit backlinks to your pages. Also, there is another thing we can conclude. Maybe you just want to host your message, your product or whatever on big authority websites, on big websites that will have high linking metrics. It's really hard to do this. But actually, well, we have something which occurred in France. This is the promo codes, okay? Promo codes, coupon, okay. So one day, the newspapers in France understood that it was really hard to make money with offering free content. So some of the newspapers started to target stupid keywords like, I don't know, very crappy content, okay, like don't eat curcuma or stuff like that. I mean, they were newspaper and they started slowly to create shitty content. And the other ones, okay, so they are the ones who have become paid, but the other ones, they said, hey, maybe we can use all of our metrics in order to propose stuff that can make money. So they started to create their own coupon website. And then they have become, for a couple of them, profitable. So what they did was using their huge linking metrics, their huge juice, in order to host stuff that were completely more profitable than free content. They started to do this. Then they started to rank on every single keyword, like verbs, like a dictionary, like stuff like that. So if you can make a deal in order to use their value, then there are some nice things that can happen. If you I don't know, if you're selling stuff, you can go to a newspaper and tell them, hey, just give me a subdirectory, link it from all of your websites, and then we can share the profits. It worked in France. Why not in Turkey? So, yeah, hosting your message on big authority websites, this is what we call the SERP domination, because you will have your website, and if you want to do like online reputation management, then maybe you will have your big, I don't know, Twitter account and Instagram account, and all of these big authority websites, you will host your message in a different way, so that you just occupy the top 10 results. So, as I said, bring some juice through clever and sometimes massive internal links. Watch out though, because if it's not done wisely, if it's done in a completely rubbish way, it can get you penalized sometimes. But I mean, I only have 40 minutes. I will not go and explain what is a good internal linking. But think about Wikipedia, for example. I mean, Wikipedia, oh, you don't have access to Wikipedia, sorry. So, yeah, so think about them. They have a really strong internal linking. And sometimes you can also add some external linking too. So use your website and use external websites. When you post your content, even if it's already great, add some more value by getting nice links. That's it. Thank you.
Çok teşekkür ederiz güzel sunum için.
Rica ederim.
Of course, we do have many questions for you, but I choose the easiest one for you.
Okay.
Not easiest one. Did you make any analysis for any other country instead of Turkey, for example? As you know, in Turkey and in any other languages is a little bit primitive for Google. So
yes.
You had the analysis for example, for the UK or for the United States?
So we did this Yeah, we did this study also in France, and our model worked better in Turkey than in France, which means that in Turkey, linking metrics are so important that we can conclude that it's the wild, wild west in terms of ranking. I mean, maybe my conclusion is that it's more spammy than what we found in France. But we will redo this study in the US and in the UK, for example, in order to make sure.
Yeah, okay, cool. Thank you so much again.
Thank you.